Summarizing with the group by clause. What does group by do? What is the group by clause used for? Group by is used to summarize, to group sets of rows into smaller sets of rows, summarized or summary sets of rows, aggregates, which is really the same as summarize and group. It is also used to analyze. We'll get into analysis at a later stage. Let's take a look at a very simple example. What I'm going to do here is I'm going to join the act and show tables on the act ID. I'm going to find the act name and I'm going to count all the shows for each act. In other words, I'm going to find out how many shows each performer is actually doing by grouping it by the name of the act. So the count function acts on the group by, or the group by acts on the count function by summing up everything or summarizing, aggregating or grouping everything into the act name. So let's run this query. And here we have it. And unfortunately our screen size is not large enough to fit it. So I'm going to go back again. I'm going to set the column. Now let's run it again. And here we have it. That's much better. Now we can see that we have, from the top, 2002 Grand National Rodeo, there are 10 shows. For instance, the Doobie Brothers, there are 3. And if we go down to Paul McCartney, there are 4 shows. And so on. Now let's run another simple example. Once again, we already have the act column set, so we want to set a smaller column for the venue. Otherwise we won't be able to see what's going on. What we're going to do is we're actually going to group by both venue and act, and we're going to count all the shows per venue per act. So really what it is more or less the same query as last time, except that we've added the venue in. As you can remember from the diagram of the concert schema, there are many acts to one venue. Let's run this query. And here we have, let's find one that we knew the answer for last time, was Paul McCartney, 4 shows, at Compaq Center. So let's go back to the previous query and find Paul McCartney again. We find he has 4 shows. Now if Paul McCartney happened to be appearing at multiple venues, we would probably see Paul McCartney with different numbers of shows coming out twice because he was at different venues. Well, we wouldn't in the first query, but we would in the second one because we've broken it up by venue as well. That's a very simple introduction to group by. It summarizes, groups, aggregates, and can be used to analyze. We will get to analysis at a later stage. All you can see here from the diagram is that I've taken Paul McCartney, Act 1, 2, 3, 4, and simply added him up into 4 shows, and here I have listing which shows they are, show IDs 1, 2, 3, and 4. At this stage, I want to make a change to the concert schema. Well, a number of small changes. First of all, I'm going to add 2 new tables, and I'm going to add a field to the show table. What are these changes for? First of all, a seating map. A seating map would be a standard setup for pricing for tickets for a particular venue. This would be applied to each show to generate ticket prices for each show. So there would be many tickets to one seating map setup because it's based on rows and sections. There is no seat number in the seating map table. The seat number is in the ticket table. So this would go by rows and sections, such as, for instance, in an arena, they generally section off the areas in large groups of seats or rows, blocks of rows, based on how far you are away from the middle of the arena, whether you're down the end, in the middle. The same would apply to a theatre where they have balcony areas and the area down on the floor, etc. It all depends on how well you can see. and the different sets of tickets in the different seating map areas are priced differently. The price multiplier column is an adjustment for each show that can be applied to each ticket. So really the price multiplier and the seating map entity and column are a setup mechanism for the tickets. The ticket table would contain the actual prices of tickets. Let's take a look at the syntax for the group by clause. As you can see, the group by clause is contained within a select statement. The group by clause is applied to rows that have been selected using a query, after where clause filtering, and before the order by clause. If you can remember from the order by is applied after filtering. And if you think about it, since you're grouping rows from the select statement into a smaller number of groups, in other words, you're taking rows and adding some rows together and creating a smaller result, it wouldn't make any sense to order by before the group by, since you want to order the result, not whatever's passed into group by. Simply wouldn't make any sense. So here's the syntax for the group by clause. You can effectively group the results of a select statement after filtering either by an expression or what's called a roll-up or cube clause, or by something called grouping sets. So what can an expression be? An expression is basically a column name, an alias column name, or even the application of a function. Generally, rollup is used as an addition to a group by clause or an extension to create subtotals and a grand total. Cube is used to create 3D crosstabs. Really what 3D crosstabs are, instead of producing subtotals and grand totals alone, you actually produce totals across the results that you're retrieving. We'll get further into that later on. Grouping sets is really used to filter out the results of roll-up cube clauses or do some unusual things with multiple groups. We'll also get to that later on. Something else we're interested in now is the having condition. What having does is, much like the where clause will filter out the results of a select statement, when group by has gone through all the results of the select statement and the where clause filtering and taken X number of rows and aggregated it down into a lot fewer rows, one row or many rows, with totals and subtotals, possibly, you can apply a having condition to the results of the group by. In other words, the rows that you're outputting from the group by can be filtered using having. So having actually behaves in exactly the same way as the where clause does, except that it's applied to the group by. The where clause applies filtering to the select statement, and the having condition applies filtering to the group by clause. Other than that, the group by clause does not affect the results of the select statement and where clause. It does not directly affect the order by clause, but group by can cause sorting to occur. Order by can be used to override sorting from select and where filtering. It can also be used to override sorting caused by the group by clause. Types of group functions. There are a number of grouping functions which are provided with Oracle. These grouping functions do generally standard things that are used on a day-to-day basis that one would expect to use as a SQL programmer. What types of group functions are there? There are aggregate functions, what I referred to previously as grouping or summarizing functions. In this case, in the example on the right, I'm actually counting the categories for each parent in the category table, and then I'm grouping by the parent ID. What I'm going to do, as you can see in the picture on the left here, is I'm going to count all the categories within each parent. So I'm going to display each parent, parent 1, 2, 3, 4, and I'm going to come up with the number of categories in each of those parents. I also have a null parent. That is actually for a category that doesn't have a parent. Those are the parent categories. If you can see the diagram on the left here, you can see there are lots of 1s, lots of 2s, some 3s, and quite a few 4s, and a few nulls at the end. When I apply this function to this category table, I actually get a result of the parent ID 1 has 10 categories, 2 has 10, 3 has 4, 4 has 6 categories, and there are 4 null categories. Categories which are parents. They do not have parents themselves. Let's go and run that query. I'm going to take this query and paste it into SQL+. And as you can see, I have the parent ID, and then I have IDs 1 to 4, and categories 10, 10, 4, 6, 4. So I could go and run the query without the group by clause, and let's order by the parent ID. There's the full description of the rows in the category table. As you can see, we have lots of 1s, lots of 2s, some 3s, and some 4s, and some nulls at the end. All the group by clause did was to simply take all the 1s and add them up. It came up with 10, etc., etc. Analytical functions. What do we mean by analytical functions? An analytical function is a function that either performs an analysis or ultimately can be used to perform an analysis. A function such as the standard deviation. Standard deviation is a statistics function. What it is, we won't worry about at this stage. However, what the standard deviation does is to analyze the data. It analyzes data and does a calculation on it and comes up with a number or groups of numbers. What I've actually got here is 2 different standard deviation functions. One on the whole of the seeding map table, and one on each part of a seeding map table where the seeding map table is broken up into 3 different groups. The venue. Let's go and take a look at these 2 examples in SQL+. I'm going to copy and paste this one. I'm going to calculate the standard deviation on the standard price column in the seeding map table. And I come up with this number. The standard deviation is 35.4923851. This is the standard deviation of each value from the mean. A mean is an average. Now let's go a little further with that standard deviation and break it up into groups. So what I'm going to do is I'm going to calculate the standard deviation for each venue across the seating map table. So last time we found a single row. This time we actually find 3 rows. So we've got 3 venues in the seating map table. Lots of records probably. If we count the rows, we find we have 693 rows. We should find that if we read all the data, which we won't do because it's a lot of records, we'll find that we have a large number of rows for each venue, and this will take the standard deviation of the price, the average distance from the mean, for each venue. There is one interesting thing to note here. Note that selecting and grouping by the venue ID has sorted the data based on the venue ID. We can prove this in 2 ways. Obviously the first way would be to retrieve all the data from the seeding map table, which I suppose we could do. If we look at the data here, as you can see, the 5s came before the 107s, and they also came after the 33s. What I'll do is I'll go and run that group by again. See, it's sorted based on the venue, based on the group by column. Why is that? Because group by will sort. As we saw, these values were not sorted. This is the physical order up here. the query on the whole table. In other words, the physical order in which the data was inserted. So what I'm trying to show you here is that group by will actually sort the data. It does do an ordering function. That's important to remember that. So, we have aggregate and analytical functions. We have a gray area between the two types of functions, because some functions can perform as aggregations and some can perform as analytics. Here's a very simple summary function. I'm selecting the count of all rows from the category table. And here's the count from the category table. 34 records. So the count function is an example of a summary function, a simple aggregate function. Statistics functions. Statistics functions form part of that gray area between aggregate and analytical functions. Statistics functions can really be aggregates or analytical type functions. Here are my two standard deviation examples again. I like to break statistics functions up into two categories: calculators and distribution functions. The cumulative distribution function is a function which is used to produce information that can be used to draw histograms, for instance, distributions of data. The ranking function can be viewed more as an analytical function. However, in its simplest form, it's not really either an aggregate or an analytical function, since it can really be used to retrieve a single value. What the rank function does is pick the rank of a value amongst a large number of values. So it says, what rank is the value 10 in this table? The result is first. We won't worry about running that function for now. Grouping analytical functions. Grouping analytical functions are applied within rollup and cube clauses. Here is a simple example of an analytical function. Special behavior of the group by clause. We're going to look at how the group by sorts, how we can actually group on multiple columns, how nulls behave with group by, and the use of the distinct and all clauses. Sorting with group by. Here I have a query that simply selects the count of all shows from the show table. It will give me a count of all the shows. I'm going to make that query a little more complicated, and I'm going to count the shows based on the acts in the show table, and I'm going to group by the act ID. So here's a count of rows in my show table, 152 rows. So now I'm going to run the group by on the act and the show ID count. This breaks down the show table into about a third the number of rows, summing up all the shows for each act. Now we'll do something different. We're going to do the same query, except we're going to override the sort order of the group by act ID. As you can see, this is sorted in act ID order, and we're going to change it to the number of shows that we counted. As you can see, the highest number of shows are down here, and the act IDs are all completely unsorted. So the group by clause will sort based on what it's grouping by, and we can override that order with the order by clause. As we can see here, my simple query turned into a group by, and then I overrode its sort order by ordering by the count on the show ID. Now what I'm going to do is I'm not going to sort based on the count of the shows, but on a rename of the count show ID column. So I'm going to group by act ID and then override the sort on the act ID by ordering by the shows column. I changed the column name, and here's my query. Now I've renamed the column to shows, and I've ordered by shows in ascending order. Group by on multiple columns. I can group by multiple columns. So here I'm selecting v.name, which is the venue name, and a.name, which is the act name, and I'm counting all shows for each act within each venue. So therefore I'm now going to group based on the venue and the act. First thing I want to do, since I'm now reporting names, which are fairly large, is I'm going to apply a format specification. Let's go back to our query and copy in my multiple column group by. As you can see, the names have gone more or less off the screen, so I can't see what I'm doing. I didn't change the names of the venue and act columns, so I'm going to change those names and apply the same query and get a readable result. Now I can see that I have, at the Shoreline Amphitheatre, I have 5 shows, 2 of them are this one, and each one of these has a single show. Now let's go and override that sort order, just to demonstrate the act of order by overriding the group by sort order, and order it based on venue within act, which doesn't really make sense since there is a one-to-many relationship from venue to act, but it will demonstrate how order by can resort group by. Now we will have venues completely out of order sorted within acts. Nulls and group by. What do we need to know about nulls and how they behave with group by? Most grouping functions return a null when passed a null value. The only function that doesn't is count. Count will always return a single row. A count of nothing is actually 0, and it will return a row that says 0. Select sum null from dual will sum nothing, and therefore will return nothing, null. Let's demonstrate that. I count null from dual and I get 0 rows. That is a single row. Group by and distinct or all. Every function can have the option of distinct or all. All is the default. So select count expression in parentheses is actually doing select count all expression. Distinct is an operator which will select the distinct values from the expression. In effect, every set of non-distinct values makes up a group. Selecting distinct will select the first value from each group. A little more about distinct. Distinct retrieves only the first row from a duplicate set, or a set of duplicates. Distinct actually will execute on a string value of the row retrieved. In other words, you couldn't pass a number directly into distinct. Let's look at some examples. First of all, I'm going to set the name format, or the column called name, to format A20. Now let's run a query that picks the categories and counts all the category IDs from both the category and show table as a join. Remember, we have a lot of categories in the show table, a lot of duplicates, and we're simply going to group by the category name, and we're going to count every single show ID. What we've done is we've grouped effectively the category names in the show table. Now let's apply the distinct clause as opposed to the all clause. Now you should be able to see the difference here. This has found all the duplications of categories in the show table. In other words, there are 9 shows under this category, there are 10 under this category. What's happened with the application of distinct is it's only found the first row or element in the show table of each category. So it's sorted by the category names, and then it's only found the first of each category from the show table. More about distinct. So we can place distinct or all into a function applied to an expression. We can also use distinct across a whole set of columns or expressions in a select statement. We can apply the distinct to a set of columns in a select statement by parenthesizing them. Note that what is parenthesized by the distinct will be the columns that will be outside of the group by clause. Let's take a look at some examples using distinct. First of all, let's count the rows in the show table. We have 152 rows in the show table. Now let's count distinct category IDs in the show table. We only have 7 category IDs. Remember this query? This is a join of category and the show table, and we found only the first occurrence of each category within the show table. 7 rows. We have 7 distinct categories in the show table. Now let's find all the actual category IDs in the show table. All these rows, 152, lots of different categories, but a lot of duplications. Now let's go and find the distinct category ID in the show table, or each distinct category ID in the show table. And we have 6, 12, etc., etc., 7 rows selected once again, using distinct on multiple columns. This gives us an error. The syntax of distinct on multiple columns actually applies to the result of the select statement as it passes through the table. So it actually applies to the string result of this select statement. Here we have 32 rows, the distinct category venue combinations. So we know that this didn't work because we've got numbers. This will work because we're going to take those 2 numbers and convert them to characters. And there we have it. Distinct requires a string. Summary functions used in group by clauses. Again, we have our initial example of selecting the count of all rows from the category table, returning 34 rows. All the summary functions. Average takes an average. Count counts things. Max gets a maximum value, min gets a minimum value, sum sums up values into a sum or aggregate. How do we deal with average? Average is applied to an expression. Here's a simple average function, the average of the standard price on the seating map. Count, as we've seen a number of times before, will count on an expression or everything. Max gives a maximum value of an expression, same applies to minimum, and the same applies to sum. Let's go and look at some examples. First of all, let's set the width of the column called name. Now let's select the average standard price in the seating map table for each venue. And we're going to group by the venue name, which comes from the join between venue and seating map. This is the average price on the seating map table for each venue. Note that our seating map table actually only has entries for 3 venues. Let's go off at a little bit of a tangent here. First of all, let's count all the rows resulting from a join between the category and the show table, an inner join. We have 152 rows. That is actually the same as the rows in the show table, which we've seen before. Now let's count an outer join between the show and the category tables. As we've seen before, only 7 of the categories are being used in the show table, so there are a lot of categories that are not used. So an outer join between the category and show tables, with the show exhibiting the deficient side in information, will actually have all the shows plus all the categories joined between show and category, and then it'll have all the categories that don't have any shows. So we have 179 rows. Now we can go and count on the category ID rather than everything. We get the same result. Now let's go and run that outer join again, except with a group by clause. And here we get an interesting result. Remember we said that count always returns at least a single row. Well, as a sum, it does return a single row. This is actually a category that does not exist in the show table, and is telling me that the join between the 2 tables is actually one show, one category. It's trying to tell me that it does have a show, which is incorrect. Really, the outer join is inappropriate in this case because count returns 1 row. We should actually be getting 0. We couldn't change that count to 0 because there might actually be a show record in the show table for a single category. In other words, there could be one show for a category. By using the outer join, I'm showing that the count function can sometimes be very misleading with group by. So let's go and do that same query again without the outer join, and we have correct values for categories in the show table. Now let's go and run a more descriptive or visually friendly query using the names from the different tables. Plus we'll use, in addition to the average and count functions that we've already seen, we'll use the min, max and sum functions. We're going to join the venue and seating map tables again, and we're going to group by the venue name. And this is a nice query. It shows me the average ticket price or ticket area price in the seating map table. Remember, seating map is not actual ticket prices but area prices, such as balcony, area in front of, area at the end, etc., etc. Here's the lowest price for that Arco Arena, here's the maximum price, and here's the total price. The same applies to Compaq Centre and Orpheum Theatre. Note, since this is a map which is projected with the price multiplier on the show table to produce ticket prices, the sum values are not really very meaningless in this case. However, it does demonstrate the use of the different functions. Statistical functions. Once again, statistical functions are divided up between those which are calculators and those which are of a distribution type of function. Here are all the statistical calculator functions in Oracle. The only ones I'm interested in now are the standard deviation and the variance functions. Standard deviation. Standard deviation is executed on an expression. It is the average distance from the average. To produce this diagram, I simply calculated the standard deviation of every value in the seating map table. The variance, as it says here, is the average squared difference from the mean, or the average. In this case, we have a line through the diagram actually showing the mean. So the standard deviation is the average distance from the mean of each of these values. The variance is the average squared difference from the average, that is, from the line. Amongst the other functions, generally we have standard deviation functions, variance functions, covariance functions, correlation functions, and linear regression functions. The statistical distribution functions are cumulative distribution function and the percent point or inverse distribution functions. CONT and DISC apply as for continuous or discrete distributions. Let's go and work with some examples of statistical functions. Let's go and calculate an average, standard deviation, and a variance for the seating map table. Those are the answers we get. Now let's go and calculate an average or a mean for the join between the venue and seating map tables grouped on the venue name. And here we have the mean of the standard price values for each of these different venues. Now let's look at a last query which actually finds all three of the mean, the standard deviation, and the variance for all the venues in the seating map table. Now let's go and look at some other functions, namely analytical functions and some additional miscellaneous grouping functions. Ranking. We've already seen ranking before. Let's take a look at an example. Let's go and find the rank of the value 200 within the ticket table ordered by the price in descending order. So the rank for 200 is the value 7,551. Now let's try to prove that the rank for 200 we found is actually correct. First of all, count the number of rows in the ticket table. we get a count of 276,750 rows in the ticket table. Now select the maximum price value from the ticket table. The maximum price value is 390. Now I'm going to select the rank of the maximum value, 390, from the ticket table. I get a value of 275,851. So how do we prove what rank is actually doing? The total number of rows is 276,750. The rank of the maximum price is 275,851, which is slightly less than the counted number of rows. If I take the two queries for the number of rows in the ticket table and the rank for the maximum value and execute it, I get a difference between the two of 899. What does that tell me? It tells me that the value 275,851 subtracted from 276,750, so let's say 276,750 less 275,851 from dual to get the result is 899 rows. What we should find is that the count from the ticket table where the price is equal to 390 should be and is 900 rows. If I take one off that, I get 899. Back to the ranking functions. All the ranking functions. Ranking functions are rank, dense rank, and percent rank. As we know, the rank function finds the rank of a value within a group or set of values. Dense rank finds the rank of a value within a sorted group of rows, and percent rank is a cumulative distribution ranking type of function. The only one we're interested in at the moment is rank. What do they do? This is how the rank function is used syntactically. It takes an expression, is executed within a group, and can be ordered by an expression. The grouping functions, as applied in the rollup and queue clauses of the group by clause. All the grouping functions are namely group ID, grouping, and grouping ID. Group ID does filtering, grouping distinguishes between groups, and grouping ID searches for a grouping level. Filtering the results of group by clauses with the having clause. Once again, the having clause is applied to the group by clause in order to filter the group by clause. In other words, you're going to filter out the things that you don't want. The groups that result from the select statement and the grouping of the select statement results can be trimmed down using the having condition. Here's a simple example. Here's the select statement, the function, which is used to apply the group by on the venue name. There's a join here between the act, show, and venue tables. After the group by, I'm applying a restriction to the group by of venues where I'm only going to allow venues which are starting with the capital letter C or the letter P, and they have at least 10 acts. As you can see from this query, with this AND logical operator, all the standard logical operator settings and precedence rules apply in the having clause as they do for the where clause. Let's take a look at some examples. First of all, let's go and get some rows. So I'm going to join the act shown venue tables and simply display them in my SQL Plus window. I run it through and I come up with 152 rows. Now let's go and group. Join the three tables, count the acts, and group by the venue name. So I'm going to get a count of all acts for each venue. And here I have the count of all acts for each venue. Now let's do the same query, but restrict the groups such that those group venue names start with a C or a P, a capital C or a capital P. So here I had all these venues. Now I'm going to restrict them with the having clause. Now I have venues beginning with C and venues beginning with P. Now let's extend the having clause and only pull up venues which start with C or P and have at least 10 acts. And there we have it. Compaq Center, Curran Theatre, those two venues all have at least 10 acts. As you can see, Caesars Tahoe South is left out because it has 2. The same for that one and this one. And Cow Palace as well. We have these 4 groups in the result, and these 4 groups are omitted based on the having clause applying a count restriction on the number of acts that it must be greater than 10. Extending the group by clause with the roll-up clause, the cube clause, and the grouping sets clause. The roll-up clause creates subtotals and grand totals. The cube clause allows the creation of 3-dimensional crosstab reports. The grouping sets clause allows filtering on the results of roll-up and cube clauses. Here's the syntax for the roll-up clause. As you can see, roll-up has an expression list applied to it and produces subtotals and a grand total. Looking something much like this, where we have a join on the venue and act tables and the ticket table with the total values of tickets. In this case, we produce subtotals for each venue, as you can see here, indicated by the arrows, for Arco Arena, Compaq Center, and the Orpheum. A grand total is produced at the end. Let's go and run through an example with the roll-up clause. First of all, we're going to join the venue, show, and ticket tables, where my venue name is in the venues I know I have, and I'm going to count all those rows. The result I get is 276,750 rows in that join, with this restriction applied. One interesting point to note: even though this restriction actually retrieves all the rows in the ticket table, I have applied the filtering before I apply the join. What that's doing is actually restricting the number of venue records I'm retrieving. The result of that is that I will only attempt to join the venue to the show table with 3 venue records rather than the total number of venue records. That's an example of simple SQL tuning applying the filtering before the joining. So instead of joining however many venue records I have, I've only joined 3 venue rows to the rows in the show table. That's a little more efficient. Let's set some column names. Now let's go and group the same join and sum the price in the ticket table. What I've done is I've got all the sums of the ticket prices for each venue. This is the same as this query here, except that I don't have the subtotals and the grand total. Now what I'm going to do is I'm going to apply the roll-up clause to the group by function on the same query, and I'm going to get subtotals for each of the venues plus a grand total for the whole query. So let's run this query. Now what I've done is Since I've only got 3 groups and no sub-values within the venues, I obviously don't get any subtotals. However, I do get a grand total. I've also formatted the numeric values, which are dollar amounts, into readable dollar amounts. As you can see, this number is 19,368,360. If we go back to my picture here, we'll see that this is the same value as the grand total. In order to get both subtotals and totals, I need to report act within venue and group by roll up on both venue and act. Obviously, since there are many acts at one venue, it makes logical sense to group by in the sequence of act within venue. So let's copy and paste this query and execute that as well. Here is the result of grouping by applying roll-up with both the venue and the act columns. Now I have a subtotal for the venues and a grand total for all venues. We can see that they're subtotals because the act column on this line is blank, so it's taken all the acts and their sums and added them up and produced them on this line. Similarly, for the compact center, we've taken those 4 acts and added them on this line. The same applies to the Orpheum, of which there is only 1, and we get the same amount on that line with a grand total down here. If we go back to our diagram, we can see that it's exactly the same as that diagram. This is the query that produced this picture in iSQL+. The cube clause. Once again, we see that the cube clause creates 3D or 3-dimensional cross-tabulation reports. What is a 3D cross-tabulation report? The easiest way is to demonstrate. Here is a 3D cross-tabulation report using the same query as we used with the roll-up, with the venues and the acts. Here we can see that we have a total for the first venue, a total for the second venue, and a total for the third venue. Down the bottom we have a grand total for all acts and venues. In here we have totals for the individual acts, regardless of which venue they're at and how many shows there are. So let's demonstrate the application of group by cube on the same query we used with the last roll-up group by function. This is the result we get. As in the diagram shown here, we get all the acts within venues with a total for the venue, applying to Arco Arena, Compact Center, and the Orpheum. Then we get a total for each individual act, regardless of the venue, and finally the grand total. Now let's take a look at the grouping sets clause. Here it says that grouping sets is used to filter groups and multiple groups. What does this mean? Again, we'll demonstrate by example. Take a look at this picture. In this picture, I've actually gone ahead and used the grouping sets clause to quite simply filter all the subtotals and totals out. How would we get to this result using grouping sets on a group by? Let's take a look at the example. I got a couple of examples using grouping sets. So I'm going to group by, firstly, grouping sets. I'm going to specify these 2 columns, this column, and this column. These are the things I want to include. In the second one, I'm going to specify these, and in the third one, I'm going to specify just these. So what do these statements do? Let's take the first one, where we've included all combinations. That means get these totals, and get these totals. Let's run the first one with everything. Here we can see the result. What we have here is all the totals. We have all the values for the combinations of the venues and acts, all the subtotals for each act, and all the subtotals for each venue, regardless of either venue or act.